Welcome to the deep dive. Today, we're jumping into a listener-submitted upgrade package. It's aimed at taking the Tamiya G601 chassis, the King Yellow or KongHead, from, well, a fun novelty, let's be honest, to something much more high performance. We're looking at a Hobbywing 1080 ESC, a big 25-kilo servo, a 550 motor, and some key support parts.
Yeah, and what's really interesting here, I think, is that it's not just a list of parts. It's presented as a cohesive system. These components, they really rely on each other. But the core insight from the material we looked at is pretty clear. You can bolt in all this fancy electronic gear, but it'll basically sabotage itself if you don't fix the truck's basic mechanical weaknesses first. The ones that are there for cost-cutting, really.
Okay, that definitely sets the stage. So if the goal is best running, like properly dialed in, what's the absolute first thing you have to tackle before you even think about plugging anything in?
Right, it boils down to whether the chassis can even handle the power efficiently. And with the G601, that's a big question. It's not your standard four-wheel drive. It's this complex six-wheel drive setup, 3 axles, loads of gears, tons of rotating points packed in there.
So lots of places for friction to build up.
Exactly. The stock setup uses plastic bushings everywhere. And, well, they create a ton of drag. Much more than in a simpler truck. If you just pump more power in, you're going to generate immense heat, waste battery. I mean, you're just losing horsepower to friction. So replacing all of those bushings with proper ball bearings, that's step one, absolutely mandatory.
And then there's that classic G601 bounce. It hops around quite a bit, doesn't it?
Oh, yeah. Those simple friction dampers, they're basically pogo sticks. You really need oil-filled shocks. Proper dampers, they're essential to control how those 3 axles move and, keep those big 113-millimeter tires actually touching the ground. Doesn't matter how much power you have. If the wheels are in the air half the time, no grip, no control.
Okay, that makes perfect sense. Build the foundation first. Let's shift to the electronics then. The source material is really specific about needing the Hobbywing Quick Run 1080 ESC. So let's put ourselves in the listener's shoes. If you tried to save some money, maybe use a cheaper stock-level ESC. But you still use that powerful 25-kilo servo. What's the failure point? What happens first?
The failure point is almost immediate, and it's the BEC, the battery eliminator circuit. See, the 1080 ESC, it has a really robust adjustable BEC. Can push out, I think, up to 8.4 volts. Pretty strong. Your average standard ESC just has a much weaker BEC. It's not designed for high-demand peripherals.
And that big servo is definitely high demand.
Absolutely. When that 25-kilogram servo is working hard, like turning all 6 wheels against resistance on rough ground, it pulls a huge spike of current. If the BEC can't supply that current instantly, the voltage across the whole system dips. That's your brownout. The receiver loses power, maybe even the ESC's brain momentarily. You get glitching, or worse, a complete loss of control. The 1080 strong BEC prevents that entire scenario.
Yeah.
It feeds the beast.
Gotcha. So the strong BC enables the strong servo. Let's talk about that servo. 25 kilograms. That's a lot of turning force. What's the problem if you pair that muscle with the stock steering parts?
Yeah, you immediately run into the next weakest link. The stock servo saver. Its job, is to protect the servo's internal gears from sharp impacts. But the stock one, it's plastic. And it's really designed for servos pushing maybe 3, 4, maybe 6 kilos of torque, tops.
So nowhere near 25 kilos.
Not even close. So what happens is, with that 25-kilogram servo, the saver's weak spring is always partially compressed, even just during normal steering. It's constantly flexing. You end up with this really vague, mushy steering feel, even though you've got precise electronics trying to do the work. That's why the upgrade list specifies the Kimbrough 124 saver. It's strong enough to stay rigid under normal steering forces, giving you that sharp response, but it'll still flex and do its job on a hard hit.
Right, precision protection. Okay, last piece of the puzzle, the motor. We're going from the standard 540 silver can motor to a higher torque 550. What's the small, cheap part that becomes absolutely critical here to avoid, instant failure?
Durability, yeah. It comes down to the pinion gear.
Mm-hmm.
The 550 motor, especially the kind typically used for crawling or trail trucks, generates way more torque, like right from the start, low down RPMs. That immediate twisting force, it just annihilates the stock pinion gear.
Because the stock one is made of
soft aluminum. It's designed for the milder 540 motor. Hit the throttle hard just once with the 550's torque, and that aluminum pinion, will either shear its teeth right off or just wear down incredibly fast. So a hardened steel pinion gear isn't optional. It's a basic requirement to actually get that 550 power into the gearbox reliably.
Okay, so we've definitely seen this chain of dependencies, haven't we? You need bearings for low friction, you need oil shocks for stability, you need the steel pinion to handle the motor power, and that high-torque servo absolutely demands that beefy BEC from the 1080 ESC. It all links together.
Exactly. It paints a really clear picture. If you, the listener, really want that best-running G601, the analysis strongly suggests you need a strategy, a tiered approach. So here's the final thought. Do you jump straight to Tier 3, maximum power, the big motor hoping for instant speed, or do you start methodically at Tier 1, eliminating those fundamental weaknesses, first the friction with bearings, the instability with dampers, ensuring power transfer with the steel pinion, building that solid, efficient platform before adding the power, because, the order you choose to invest in, that really decides if this whole upgrade package leads to reliable performance, or just a really fast way to find the next weakest link and end up with a frustrating broken truck. Something to think about.